Hello, everyone. My name is Chonghwa Seo, and we have our student researcher here. Maria, would you introduce yourself?
Oh, hi everyone. My name is Maria Bernaldez, and I am a junior at Shauna University, majoring in environmental and interior design.
And I am her research mentor and also a associate professor in arts and design at Shauna University of Honolulu. And today we are going to talk about interactive recycling system that encourages green behavior of our users in the building. So we are going to talk about some framework and also the design proposal to, and also the ways to encourage green behavior.
Starting off with the introduction, we all know that recycling is proven, known, and taught to be a very sustainable practice to help us move towards a greener future. And it will help improve our resource management as well as closing the loop for our waste consumption. And recycling is defined by the EPA by the action of collecting and processing materials and turning them into something new to use. And today we will be going over some of the issues and flaws within the US current recycling system, which is lack of education, shipping to other countries, and how economics plays a part in it.
So we are going to go into the methodology part. So this study uses primarily interpretive historical research as a basis to create an evidence-based design proposal. So we have done extensive reviews on current recycling system in the US. And also we have looked at some of the case studies in Japan and Germany. And Japan mainly was explored because of the cultural integration aspect of the recycling system. And for Germany, we have looked at how they did technology and education integrated recycling system. And also we have looked at some of the literatures talking about how interactive learning and artificial intelligence, the combination of those two really support the communication and also the more effective behavior on the recycling system. So with the knowledge and learnings, we have looked at the site, which is that our university, the University of Honolulu, and as the basis of the site context. And then we have proposed the design integration proposal based on the learnings that we have from the literatures, but also looking into what kind of future research that we are going to proceed with this. Okay, so we are going to move on to the next.
So moving on to the analysis, we're going to start with the US three main issues, starting off with education. So education plays a huge role when it comes to our recycling system. However, according to the US EPA, there is a confusion on what cannot and what can be recycled, which leads to most Americans sorting out the recyclables and trash improperly because there is confusion between the different types of plastics, as you see here in the image, like types of plastics from 1 to 7. And with the confusion, that also leads to contamination if it has reached the trash or if it's contaminated with leftover like residue of your sports drink, or if there's food in it, it cannot be processed and it needs to be rinsed out. And the types of plastics we will go over in later. So for the second main point, it is shipping. especially shipping to other countries. And it's been an issue for a while that the US has been shipping their recyclables and trash to other countries. And in recent years, around 2016, the US has been exporting their mixed recyclables and waste to other countries such as China, Vietnam, Malaysia, and Thailand. As you can see in the picture, that is some of the recyclables that has been sent to Malaysia. And China has actually put a ban saying that they don't want the US to be shipping any of that to their country. So the US around 2018 has diverted all of that to countries with lenient environmental policies and rules such as Senegal and Cambodia. And all of this ties in with the economics. So there is a choice for people and facilities. So they have a choice to either pay to recycle and pay for the processing fee, to sort, to clean, to have it in like tiny pieces and to heat it up and make into something new again, or you pay to discard it altogether. And with how it is these days and recently, the cost to discard it altogether is cheaper than the processing fee, and people will usually opt out for the cheaper option. And the increased flow of the plastic and the consumption of waste, it cannot keep up with the processing cost. And that's why it's leading up to how everything is expensive and people don't want to be paying more for everything. So taking a look at Japan with the cultural integration, what we found is that in Japan, they have a strong and strict systems with a lot of rules and regulations for sorting their waste and recyclables properly. And this is because if they don't sort it properly, they will have a penalty. And everyone around in the neighborhood is always instructed, and it's been like that for like generations, that you have to sort it out properly, or else when they come to pick everything up, they will have a notification saying, hey, we're not going to pick it up until you sorted it out properly. And in Japan, it's known as very shameful because it means that you don't know how to sort something simple out properly, and you don't want to be labeled as that person in the neighborhood. And also Japan has this very strong mottainai culture, and it basically translates to you don't want to be wasteful with anything, and everything it serves a purpose. And since everything serves a purpose, you don't want it to like go to waste because nothing is wasteful. And that's been integrated and instilled to the generations, and they teach that to their children. And the recycling is usually promoted there, and everything is processed within the country. As for Germany, their strong point is their education system, as well as integrating technology with different machines to have and like store all of the recyclables. And within their education system, they teach primary and secondary institutions about little small recycling details, like the types of plastics, the types of pollution, and how everything will build up, as well as plastic production and consumption of how we use things, to a bigger picture. And they will also have classes where they will have local cleanups, and that instills that everyone to know and be educated that this is how you do things properly.
So from the case studies that we have seen from Japan and Germany, and also looking at the current issues in the US, we have found that probably some of the interactive system may be the ones that could improve the behavior. And this literature shows that social interaction is a core aspect of a human behavior that sustains the multifaceted social systems underlying our society. So basically, recycling system is a part of our society, and that is something that is very important going forward with the greener future. So we were thinking that how interactive systemizing interactivity into the recycling system is very important. Also, the research shows that penetration of the information and communication technology in society is very important as well, because it improves the communication and also increases the spread of knowledge and the education pieces. So using of artificial intelligence would improve the quality of life, which translates to the more effective recycling system. Okay, so we're going to move on to our comprehensive recycling framework. So based on our the previous research and the literature review, that we have found that we need to think about how users are going to approach our recycling bin system that we create, how they're going to find it, and then what they need to find it first and then approach, and also the check that certain things is recyclable or not. So recyclability needs to be checked, and then it needs to be cleaned and also prepared properly. And then the recycle is going to be done. So that framework, this framework we created will inform our design proposal. Okay, so that leads us to smart interactive recycling system. So basically this is kind of mapping of how our recycling system is going to be mapped out as we are designing whole system at Chaminade University of Honolulu. So basically we are going to propose the one that is technology integrated, and basically technology is going to tell us that if this is the right things to recycle or where to recycle, and it is prepared correctly to recycle at that point. And once that is clarified, then it goes through that it encourages certain action from the users that you need to go clean it, or you need to actually get rid of the cover, or what other actions that they need to take. Or if it is prepared correctly, then they can actually put it in the action, which is inserting in the proper slot. Then that goes into that, it tells them that how this is going to be recycled. And also in that process, then users are going to get educated that certain items that they're recycling and what kind of recycling, the symbols and what that represents. And then if they're recycling correctly or not, then they can check and get the feedback from the systems. So in the future, then they can actually do this recycling system more effectively. So we're going to talk about some of the ideation that we have done based on this framework and also recycling mapping that we have created. And then we're going to talk about the design proposal.
So for the design ideations, as you can see with my little sketch in the left, that was my first initial idea of what it would look like with technology. And I started off with it being something like standing up. And I wanted to have that integration of technology to scan what the material is, and if it was like contaminated, and if it was contaminated, or if it's the wrong material, like in the wrong bin, then it will notify the user on the little screen. It would show you and tell you that like, hey, it needs to be rinsed out thoroughly, or you need to take out the cap, or you need to take off the label. And you would have to put it in the correct bin to have it actually placed, like have it placed within it inside the bin. And moving on into a little bit of it being flushed out, I then thought of it, or we then thought of it as how it can be incorporated within the building system. And within the building system, for the location, it would obviously be next to a restroom so that it's easier and close to the user so they can rinse it out quickly. And you still have that scanning system, like to check everything. you're scanning it. So you're checking in on the screen, it would show you like the type of material, it would show you like if you've done everything properly, and it would educate the user of the material that you're recycling, as well as what other things you can do. And obviously, if everything checks out, then it will go into the bin and it's properly stored and everything is cleaned out and rinsed, and the cycle will obviously go all over again. So for our design proposal, this is what the built-in system would look like in the Chaminade hallway. And it would start off with a scanning analysis. And you would insert the item like the bottle or the can, and it would, the technology would scan for any contamination of like any liquid residue, food or trash residue, and it also determines what the material is. And when that's scanning, what you'll see on the screen will show you the information that you need, such as if it is contaminated, hey, it will tell you that it needs to be rinsed with water, or maybe you didn't have your label removed, you need to remove it. You need to have your cap removed because it's not the same type of plastic, and it will tell you if the material is the right material for that bin. And moving on to the education part, it will educate the user of the type of plastics. And the type of plastics, as I mentioned before, is 1 to 7. And the main types of plastics that are accepted and processed is 1 and 2, which is PET and HDPE, which is polyethylene terephthalate and high density polyethylene. And those are the main 2 that are processed. While 3 and 7 is often accepted and said that it's recyclable, but it's not processed here, and we don't process it here in the US. So we like to believe that it's recyclable, but in reality, it's not processed in the US and it's not recyclable here. And that leads to the action. So when everything is scanned and you get to, and you're educated and everything checks out, then you would obviously put it in the bin.
Yes, so once the user actually put the item into the recycling bins, the proper recycling slot, then it's going to be collected until bin is full. So the bin itself is not going to be shown in the public, but it's going to be having this collected here. And as you can see, that whole system is integrated in the building. So we are proposing this system is more building integration rather than it is something that is add on later on. So it can be actually considered as a part of the whole system in the beginning. Once it is collected and it is full and ready to be transferred, then it's going to be transferred into our school main recycling center. So the idea is that there is a pipe system that is going to be integrated on the wall, and that's going to be sent to, all the items going to be sent to properly into different slots of that school's main recycling center. So community-wise, we can just have this system set, and the community level that has been all correlated correctly, right? Sorted correctly. So before it goes out to public, then it is actually once done first, the recycling correction first. So the way that we can use the recycling items and the reusing it, certain items versus some things needs to be completely discarded, we can actually do that filtration here first, and that makes the whole system a little bit easier in the larger community level. Okay, so we are going to we just wanted to review all of those. Okay, so next we are going to kind of wrap up our process here and our research. So Let's talk about what we have concluded and then what is our future studies going to be.
So as our conclusion, we believe that it's important to have an interactive recycling system, because when the user interacts with the technology and everything that is integrated within the wall, it encourages the correct recycling behavior, so they know how to recycle properly, and they know now like the whole process to clean everything out and what materials can be recycled. It increases like, a lot of interactability with the system being used.
And also establishes a better education program for recycling, would help US citizens understand what they can do and what to do it properly. I think education portion is very important in the effective recycling system, and that is something that we want to improve in the system. And also the future research can explore the ways to communicate learning moment, this education part, information better with the users, and see how recycling behavior improves over time. So that is something that we are going to start further our research in our community, Chaminade University community, that maybe we cannot integrate this technology system right away, but we can at least start integrating this learning moment system. So one of the ways to integrate this system is using QR codes. So we are starting to using the QR code in our recycling zone, and people can actually get the information on what can be recycled and what cannot be. So it can start encouraging the behavior of the correct recycling in our community. So further on, then we can integrate this technology system more. So is this AI system or any other communication technology system to improve this recycling overall system better. So here is our references that we have used. There are furthermore, but this is what we have in this presentation. And mahalo nui loa, thank you for listening to our presentation. And hopefully we can improve our recycling behavior better overall in our community, and hopefully that leads us to the better, greener future. So we can actually protect our environment and also protect our community. Thank you.